Dear students, now we'll move to problem number 37, okay, in the tutorial number 2. In this problem here, you can see, let's read the question first and then we can answer it easily. So, determine the electric field E at the origin O. So, this is the origin O, okay, here, so this is the origin, okay. So we should always ask ourselves where we should find the electric field, okay? So where is the place? And it has been given that we should find it at the origin O. Okay, so this is the figure. Due to the two charges at A and B. So we have two charges, one here and the other one is here, okay? So now we're having these two charges at that place. They will affect, okay, all the points around them, but we should only look at the origin there, okay? So what is the P here? What is the electric field at the origin? This is the question. Actually, the electric field there, okay, it is just the effect which comes from the Q at A, which is positive charge, as well the effect of the Q at B in this point. So we have two effects actually, or two electric field. But because we are taking account of the direction, we should draw the electric field. You can see here, this is A, point A. So now the electric field will affect here at point P, as we said here, okay? So the resultant, because this is positive and this is actually just a test point, which is at origin now, so then we have the result is going outward from the point. So EA is pointing outward. The same thing to Q at point P, because when it just interact with this point, it will make EB, which is the electric field at the origin, coming from the Q at P, and the direction will be also outward like that. So we have one is going that direction, and the other one is going to the left, okay? Okay. Now, by looking to the triangle itself, so forget now the solution or direct solution with equations, just see this triangle now, A, B, O. This is O, okay? This is the origin now, okay? You can see all sides here are equal because we have the length here L and here L, here L, okay? Because they have the same side, okay, amounts, but this is L, so then this will be 60 degrees, and this is again 60, and this is also 60 degrees, okay, because the sum of these is 180 degrees, okay, all the inner angles inside a triangle, they should be equal to 180 degrees, okay. If this is 60, that means also this is 60, yes? So this is 60. And we know if we can complete this one little bit like that, we know that this will be excellent 30, okay, degrees. So now we have EA, which is going down in Y direction, so no problem with that one until now. But we have a vector, it has two components. One is going with an angle with the x-axis, and the other one also is going with an angle to the y-axis. Because this one is going to the x-axis and just covering this angle, so we call it, yes, excellent, we call it E, which is coming from B, cosine, yes, cosine 30, excellent. So this will be in the x direction. Again, this one, it has also another component in y direction, okay? So we know that this is the angle 60, but we'll take the same angle because we took it up there. Now we take it, yes, excellent. E, B in y direction, this time sine 30, okay? So some of you may say, why we have here sine 30, cosine 30? We can take 60, yes, you can take 60 actually. It's up to you. You can take 60. If you take 60, here it will be cosine 60. If you take 60 angle, the angle 60 between the vector and the y-axis, in this case it will be cosine 60 like that, okay? You can put it together. And actually these are equal. This is equals to this one, the same thing. Okay. And also here, if you take this one cosine 60, you should take here cosine what? Sine 60. And also sine 60, okay, equals the same to cosine 60. Okay. So in this case, let's see what they did here. You can see here the solution starts EA equals to KQ into divided by L square. Why L square? Because this is the R, the distance from the origin, which is here. Let's take the color here now. So this is the origin here. Okay, you can see the red point there. Okay, to A. So this is A here. So the distance here is L. So this is the first equation between for the electric field at point P. And then we know that it has, this electric field amount. Why it's minus K? Because it's going to minus Y. They're trying to make it to the minus Y. So this is the EA going to minus Y. Okay. Let's now see the other one, which is B. Going actually B to the point B, it has a vector with two components. So this is why we need to find EBR, okay, and also EBY. And actually this is EAY. This is not X. It's going to Y direction. Okay. Why it's negative? Because it's going to the, let's call it minus Y direction. But as I told you, if you draw it, if you make the drawing, no need actually for signs now here. Okay, it will be very easy for you. Okay. So we have an EA at Y direction coming from A to B. Okay. And also we have EBA in the same direction, sine 30, as we find it just now. So we have two electric field directions or intensities with the same direction. Okay, so both of them are in minus Y direction. This is going down now. Okay, that's fine. So we have this one. It is the same direction of that one. This is why they make a minus sign here and a minus sign there. Okay. What about this one here? This is actually the X direction. What X direction we have here? We have actually also to the minus X here, which is EB, as we make it here, EBX cosine 30 in this case. Okay. So this is actually the same thing here, the magnitude here. Okay. Having all of this, we can draw them here easily. This is the point O, the origin. Okay. Then we have one is going there, which is E, as we said, AAY. And then we have another one here. It's going down also. This is E coming from B, from charge B in Y direction. Okay. We have another one which is in this direction, in the minus X. We call it, yes, EB in X direction. Okay. So we have these three forces. Now we should look for the, first of all, we should add all of these two. These are in the same direction, so we should add them together. Okay, so add them together. After you add them together, what you should have at the end, you have these two together here. Okay, and then you have this one, which is EBX. These we can call them, let's say, ER1. Okay, because we add them together. Just for instance. Okay. Okay. Or EY, we can call them EY here. Again, it's up to us because this is going in Y direction. Okay. Now we have two vectors with a 90 degrees in between. They are perpendicular, so we can use the Pythagorean theorem. Okay. Pythagoras or Pythagorean theorem, okay, it can be used here. As you can see, this is the Pythagorean theorem. Okay. After we prepare X, which is this one, okay, and then we have Y, which is also the addition of both of them from the beginning. So now we have X and we have Y. We just multiply here with, we should get E, and we know one of them is going that direction and the other one is going there. So to find the final result, we should move one of the vectors, one of the tail of the vector to the tip of the another one, and then we should get the resultant vector here. And this is, we call it the final ER or E. Okay, so we're looking for this actually. But how can we get that? We need to have the magnitude, which is this one, calculated from here, and we should also find the direction. And we can use actually any of these angles to find the tan theta. We call it tan theta or tan inverse because we are looking for theta actually. So tan inverse of the y magnitude over the x magnitude, which is the electric field in the y, and this is electric field in the x. Okay, and from here we can get the result. As you can see, this is again, this is ex, this is ey, as you can see, and this is ex. You will ask me, you said, oh no, this is not the one that calculated here, this is ex here, it's the same like this one. I'll say yes, you are right. It depends on the angle that you are looking for. If you are looking for this angle, okay, so then you see this is 90 and 90, and then you add that one, and then you reach 240. So you added actually 50 like 60 degrees. So it will be another 60 degrees here. Okay. Okay. So it depends actually. It depends on the angle that you are trying to get. Usually we are taking the angle with the x-axis in this case. Okay. So again, what we are trying to say, if we have the result like this, so you should find this angle here. Okay, let's say this is 60, and then this is actually, it can be 60. Yes, it is 60 with the minus x, but also it is like 90 plus 90, 180. So this is 90, this is 90, 180 plus 60, it will be 240. Okay. But somebody else can say, no, we can measure this one. Okay. If this is 60, this is 30, and this is 90. So 90 plus 30, it will be 120. Okay, so it will be 120. But this will be with minus sign. So that means if you choose to start from this point, going that direction, for the angles, you should make a minus sign here, so we can understand that you didn't start from 0 going up, but you're going down, which means anti-clockwise. Okay, sorry, clockwise in this case. Okay. You see, now we get the result, and then we get also the angle here. Angle is very important. Okay. Okay. Now the question doesn't finish here. If you can return a little bit back, you can see the question said, repeat the same question here again. Repeat it again, but change the sign of the charge at location B. Okay. So this is the location B here. It was positive. If we make it negative, what will happen? We will not go through all the results and explanations, but we can say something here. If this is negative, negative, so if this is positive, okay, positive at the top, and here it is negative Q, this is positive Q, okay, and they are affecting this point here, which is the origin. Okay, let's take a space first. Okay, so we have Q1, okay, and then we have Q2, and we have here the origin point. So if this is negative now and this is positive, we know positive with positive, it will go a little bit to that direction. This is actually the distance. Don't forget the distances. So this is L, L, L. Okay. So this is the electric field coming from charge Q1, because this is positive and this is test charge. Usually we are taking this charge as a positive. Yes. But if it's negative, so then in this so then the effect will be, or the direction of electric field which will be in red now, it will be to that direction here. So this is E from B, charge on B. And this is actually the previous one here, it will just be E from A. This is point A, this is point B, okay? So now you can see, what you can see now, that the direction of electric field coming from the charge at point B is going to that direction, okay? Now, what we can do now? Now we can see easily EA is always going down, no problem with that. But we have now EB is going also with a vector, but this time with an angle with the positive x-axis here. Now we should find this angle here again, okay? Oh, that's easy, I think, for you, because you already knew that this is 60, yes? If this is 60, so this is? Yes, excellent, this is 30. So I can analyze this vector into two components. The x-axis will be cosine, okay, cosine 30, and this will be sine 30. As we said, this is just covering the angle here, okay? And also you can use the Pythagoras theorem here for getting the electric components in x and y directions, okay? Let's now see what they did here in solution, okay? Now this is EA as usual, okay? Y is minus sign going into minus y, okay? Now EB, it will go to the, yes, excellent, to the toward Q at location B. We take cosine 30 in this case. It is a positive sign because now it's going to be here actually. So everything is positive here. So we have this result here. So this is the result of the electric field to the B direction. If we take it with sine 30, so that means this is in X. Okay, so this is actually in X direction. Okay, so we have here in the sorry, I'm sorry. This is in X. This is in X cosine 30 as we said, but this is sine 30. Okay, so it will be to the top here. So we have here cosine 30. This is theta, and we have here sine theta. Okay, for this component. Okay, so it's only for one vector, which is EB. It has two components, as you know. So this is for the X direction and this is for the Y direction. Then we should see what the things that we should add or subtract. You can see there. In the X direction, we can see that we have, as we have before, okay, there is EAX, which is coming from A, and EBX, which is coming from B. Okay, and then we can add them together. And if you have, I mean, two components, you should add them. If only one, that's fine. So we have only one. Okay. In this case, only we have one because the other one actually is going down here. Okay. So the previous one is going down. Okay. Which is this one here. It's going down. EA. Yeah, here EA is going down only in Y direction. This is why we have minus sign here. That's fine. What about X? X only we have this component. But now we have two components. One is going down, and the other one, which is this one, going up. This one here. Oh, so we have here two components. Yes, we have here now two components. One is EB sine, which is this one, EBY, which is EB sine 30. And the other one is actually, it is the opposite here, which is coming from EA, okay? So in this case, we're adding positive with negative values here, okay? And we can get the final result to be like that, okay? Why is the result like this? Because sine 30 is just half, okay? Which is like that one, you can see here, K, okay, KQ over 2L square. Okay, if you subtract this one, the positive one, from the negative one, which is, we just found it before, this one here at the top here, okay, you can see that the result will be this one, okay. Again, now what we have at the end of the day, if this is negative, actually we have a force going down, sorry, electric field going down, which is this result. and then we have one is going that direction. Now we should add them together, so we move the top one here, or the tail of that one, to the tip the other one, and then we can make our resultant value, Pythagoras theorem here, and then we have this angle, and we can find the angle easily. Okay, you can see they make it like that here, and this is the result. They got it without any numbers, no problem with numbers now. Okay, here again you don't have numbers, but everything it can also neglected, or sorry, cancelled, even k and k, and then you can get this result. And this is again, it is like saying like that, if this is the resultant, so this is the angle actually, which is 330. Okay, it's the same thing, but only we just change the sign of Q at P location. Okay, so we finish with that. Okay.